Okay, we're going to continue with 14.3. We saw that given this function, del f del x was 2xy cosine of x squared y plus y cubed. And what we want to do is we want to compute del f del y, which is first take the derivative of the outside function, which becomes cosine of x squared y plus y cubed, and then times the chain rule, take the partial derivative with respect to y of x squared y plus y cubed to get, so here now remember, we're viewing x as a constant. Viewing x as constant, what we get is, so x squared is like a number, we just get x squared left over, x squared plus 3y squared times the cosine of x squared y plus y cubed. So again, for this term, x squared is like a number, So if you had 4y, the derivative of 4y would just be 4, and hence the derivative of x squared y is just x squared. So this is our final answer for the partial of f with respect to y. And again, this is also notated f sub y of xy, and this upper one is f sub x of xy. Those are another notation for the partial derivatives of x with respect to y. Now, what I'm going to do here is I'm going to take a second order derivative, because here this function, so f sub x of xy, which was just 2xy times the cosine of x squared y plus y cubed, this is a function unto itself. So this itself, we can take f sub x. So there are 4 second order partial derivatives. So what we're going to do is we're going to take second order partial derivatives. Well, what are those? There are 4 of them, and let me just list them out here before we actually do any computation. So there's taking the partial derivative of x and taking the derivative of that with respect to y. This is f of f sub xy. This is another notation, the partial with respect to y of del f del x, which is del squared f del y del x. So this is equal to fxy. So this is one derivative. Another derivative is taking another derivative with respect to x itself. So this is fxx, which is the partial with respect to x of del f del x, which is equal to del squared f del x squared, and that's equal to fxx. And there's 2 more, and the same things for when you start off with the partial with respect to y. So if you take the partial with respect to y, you can take its derivative with respect to y, which is fyy, which is partial with respect to y of del f del y, which is del squared f del y squared. That's the third one, and the fourth and last one is taking the partial of f with respect to y and then taking a derivative in the x direction to get fyx, which is the partial with respect to x of del f del y, giving us del squared f del x del y. So we have 4, 3, 2, and number 1 right here. So what we're going to do is we're going to compute all of these for these particular examples. where we've already done the partial of f with respect to x, as well as the partial of f with respect to y. So let me list everything right now that we've done. So we started off with f of xy being the sine of x squared y plus y cubed. And we saw that the partial with respect to x was 2xy cosine of x squared y plus y cubed. And we saw that the partial with respect to y was x squared plus 3y squared times the cosine of x squared y plus y cubed Okay, so what we're going to first compute now is the partial of x. We're going to take that function and take the derivative with respect to y. So what is that? Well, we have two functions in y. Here's the first function, here's the second function. So we use the product rule. We're going to take the derivative of the first function, so del by del y of 2xy times, and we'll leave the second part alone, cosine of x squared y plus y cubed, plus we'll leave the first part alone, 2xy times the partial with respect to y of the second part, cosine of x squared y plus y cubed. Okay, and so let's do that. I'm going to zoom out just a little bit so I can see the whole thing here. This is equal to the partial with respect to y here. We get 2x as the first part times the cosine of x squared y plus y cubed, and then plus 2xy would remains there. And then here the derivative of cosine is negative sine x squared y plus y cubed. Okay, fxy. And that's, well, we're almost done here. We have another chain rule, right? Because we have derivative of cosine is negative sine times the chain rule, the derivative of this inside portion with respect to y. And the derivative of that with respect to y is x squared plus 3y squared. Okay, and this gives us our full fxy. This is fxy. Okay, and I didn't simplify it. The reason I didn't simplify it is because I want to show, so what I want to do here, what I want to show, WTS, want to show is that fxy is actually equal to fyx. And this is going to be a general statement for functions that are sufficiently differentiable. Okay, and that's essentially going to be most functions for us. So this is a general fact for functions that are what's called twice continuously differentiable. Okay, so this is a general statement, which I'll again state at the end of this exercise, but this is what I want to check. So fy here was x squared plus 3y squared times the cosine of x squared y plus y cubed. And what we're going to do now is we're going to take the derivative of that with respect to x, and we're going to check that that's the same. So fy, we're going to take the derivative with respect to x and show that that's actually the same as what we had for fxy. Here we go. So this is fyx. So we're taking the derivative of f sub y with respect to x. So again, we have two functions. We have this piece and then the cosine piece. So let's take the derivative of the first, which is just 2x. And then we have cosine of x squared y plus y cubed. Okay, and notice that's exactly the the first term right here. This term is exactly the same as this term. And then we have plus, we leave the x squared plus 3y squared alone, and take the derivative of the second part, which is the cosine of x squared y plus y cubed. So we have times negative sine of x squared y plus y cubed times chain rule, the derivative of the inside, times, I'll write this explicitly, d by dx of x squared y plus y cubed. And so what you end up with is you have 2x cosine of x squared y plus y cubed, and then here plus, and I'm going to leave this in the same form just so we can see that it's exactly the same as the other derivative, negative sine x squared y plus y cubed, and then times the derivative here with respect to x, we just get 2xy. And notice that this term, I'll just circle it, that this piece right here that we just got is exactly the same as this piece. So these are the same. And that's a general statement. So let me write that down separately again. So note here, fxy is equal to fyx. And that is an important fact. It's going to be the case whenever we do this. So last but not least here, let's compute. We have two more derivatives to compute, fxx and fyy. I'm going to do one of them and I'm going to leave one as an exercise, and then we'll move forward into the next video. So fxx here, what was, let me write down what f sub x was first. F sub x was the partial derivative here with respect to x, and that was 2xy times the cosine. So we have 2xy times the cosine of x squared y plus y cubed. So what we want to do here is we want to compute fx and take a derivative with respect to x. So this is derivative of the first piece, we just get 2y times the cosine of x squared y plus y cubed plus 2xy, and then we have the negative sine x squared y plus y cubed times chain rule, derivative with respect to x, we get another 2xy here. I'm not going to simplify, I'm just leaving it as so you can see all the pieces. So exercise, so given that f sub y was x squared plus 3y squared cosine of x squared y plus y cubed, find fyy. Okay, we're going to stop here. We will continue next time with this particular exercise.